Hi, class. This is Mr. G, Mr. Garcia. So we just finished 1.7, sorry. So we finished, we're done with it already. That involved functions, okay, if it's a relation or if it's a function, okay. Now we're going to look at interpreting graphs and functions. So we're on 1.8 now, so make sure you guys have that out, okay. Interpreting graphs and functions. So make sure you guys have your name, period, date. Make sure your writing is much better than mine. Anyways, so let's go ahead and start. Okay, so at the beginning of every lesson, we have an essential question. So our essential question is as follows. Our essential question says, what are the key features of graphs? So you've seen graphs already, right? It's seventh grade, and you've seen more at the beginning of this year. There's some features that you need to remember from these graphs, okay? And they're very important, okay? So make sure you highlight, circle, underline that. All right, first feature we're going to look at is the X-intercept. And the second feature we're going to look at is the Y-intercept. X-intercept, Y-intercept, okay? X-intercept, Y-intercept, okay? Now, let's look at example number 1. So example number 1, it shows the height of a launched object. So this could be a ball. Okay. So let's make believe this is a ball. So somebody's throwing something. Okay. So is this linear or nonlinear? So this is nonlinear, right? It's not a line. This is a parabola or a curve, right? So this is not a line. It's a curve. We'll call it a curve for now. It's a parabola, but we'll just call it a curve for now. Okay. Now, the y-intercept, the x-intercept. So the y-intercept is when this curve crosses the y-axis. This is your y-axis. This is your x-axis. So where does this curve cross the y-axis? So it looks like it crosses it at 16. So remember, this is your x, this is your y. So this you're going to put 16. And then your x, it's at 0. That's where it crosses the y-axis. 0. Okay? For your x-intercept, where does this graph cross the x-axis? It looks like it crosses it at 7.4. So we're going to put 7.4. And then on the y part, it's at 0. So the y-intercept crosses at 0, 16. And then the x-intercept crosses at 7.4, 0. So the y-intercept means, in this case, at 0 seconds, object is at 16 meters. So at 0 seconds, object is at 16 meters. So it looks like somebody's going to throw the ball and they're on top of a house. Okay, so they throw the ball. And the x-intercept at 0 meters, meaning when the ball's on the ground, 7.4 seconds passed. So that means that somebody stood on top of a house at 16 meters and threw the ball. They threw the ball, whether they threw it up or they threw it that way, it went up, right? It went up as high as these meters high, and then it fell down. And it fell down to 0, meaning below. It fell at after 7.4 seconds. That's how long it took for it to fall at 0. 0 meters. Okay. All right. So now we are at example number 2. Number 2 is a sample that has to be thawed. Okay. So this could be, it's a medical sample. So this could be like blood, plasma. Okay. So this is at very extreme temperatures, cold temperatures. So is this linear or nonlinear? This is linear. Okay. Now let's look at the Y-intercept and X-intercepts. So your Y-intercept and your X-intercepts. So your Y-intercept, it crosses at 0, -5 degrees. 0, -5 degrees. And the X-intercept is, it looks like it crosses at 1 and 1 hour. So it looks like it crosses at 1, and then this is 0. Okay. So to interpret this, at 0 hours, the sample is at -5 degrees. Okay. And then for the X-intercept, after 1 hour, the temperature is at 0 degrees. So it's going up, right? It's thawing. It's getting warmer. So that's example 1, and that's example 2. On this one, so when finding the X-intercept, okay, the Y is always 0. So it's always going to look like this, X and 0. And then for the Y, it's going to look like this, 0, comma, Y. All right, that's example 1 and example 2. You will get a quizzes here shortly. And we are on 1.8, guys, remember. All right.